I guess we can get started. So it's nice to meet you all. I'm excited to be talking to you today. My name is Daniel Lumi. I'm the Senior Product Manager of ZK Stack for ZK Sync. And today I'll be presenting to you guys Rise of the ZK Network. And ZK Network and ZK Stack are our vision for scaling blockchain to the mass markets, to actually be able to scale where everyone in the world can use it. And just a little bit of a legal disclaimer that we have a world-class team of cryptographers, of engineers, of mathematicians. So everything we talk about, we think is factually true, but we always encourage people to do their own research. Don't trust, verify. So first, we'll talk a little bit about what is Matter Labs, which is where I work, and how does it relate to ZK Sync. So Matter Labs is one of the leading zero-knowledge proof companies out there. We've raised over $250 million, and we really have a world-class team of, again, engineers, cryptographers, mathematicians, from companies like SpaceX, Apple, Google, and we really, our team really is quite excellent. We're the leading ZK blockchain out there, so not just in L2s, but in L3s. We have our blockchains proven with over 30 million monthly transactions. Currently, each ZK chain, so ZK Sync Europe, for example, can handle over 200 TPS. It's about 150 to 200, depending on the transaction complexity. So DEX swaps would be closer to that 100, 150. That's compared to some other ZK blockchains like Polygon, which handles 3 TPS max. But all of the L2s, they can handle essentially between 3 TPS to 20, 30 real TPS, like DEX swaps. But we perform regular upgrades on this, so we should be seeing 500 TPS soon, and then later on to 1,000 and beyond. As an L2, we're secured by Ethereum, the full security of Ethereum, and we use zero-knowledge proofs to achieve that. And our goal for ZK Sync is to make it limitlessly horizontally scalable, so you can get it to 7 billion people and beyond, while still being cheap at any arbitrary scale and keeping all the security and decentralization. Because that part is essential. Like, we can't make compromises. If we start making compromises, there's no point in using blockchain anyways. You should just use AWS or the current banking system, right? So again, we are layer 2. So we do off-chain computation off of Ethereum, and then we use zero-knowledge proofs to essentially to verify to Ethereum that every state transition happened correctly, and all of those thousands or hundreds of thousands of transactions essentially were executed correctly, and Ethereum does not need to re-execute those transactions. So we're scaling Ethereum using zero-knowledge proofs. And first, we'll talk a little bit about the dilemma, as we like to call it. Before you jump on me for the trilemma, the dilemma. And this is sort of the problem that every single blockchain in the world has. It's a feature, but it's also a bug. And this is true for every blockchain until this new vision that we're building out, which will become the next generation of blockchains. So just to get an understanding of why does blockchain not scale, we'll take a look at first of how the internet scales. And just as a mental model, let's say you have a video game on your computer, and then you boot up Excel, and then you boot up Chrome. At some point, your computer is going to run out of resources. Like, that Excel is probably going to crash it. But the reality is, like, you cannot run every single application in the world on one computer, no matter how beefy. Even if you have a giant gaming PC or supercomputer, it cannot handle every single application being run in the world. And so how does the internet scale or fix this problem? How do they deal with this problem? Well, let's say that you have 1,000 people wanting to pre-order the new iPhone, right? So the first 1,000 people will get it from server A, and that's fine. But if you start having hundreds of thousands or millions of users, at some point that server, like in the previous example, is going to run out of resources. It just cannot handle all the throughput in the world. So what Apple does with this, or any website, any web to the internet, this is how the internet scales, is they copy the state of that website onto a second server, and then the next 1,000 people or whatever amount of people can get the website from the second server or third or fourth, and you can just sort of keep scaling, and the user never has to be aware of which server they're using. So the internet essentially scales linear to the amount of resources allocated to it. So if you have one server with X resources, you have 1x scalability. If you have 10 servers with the same resources, you have 10 times scalability, or 100 times, or 1,000,000 times, as long as you just keep adding more servers to it. And so how does this compare to blockchain? Like, why can't blockchain scale? And this is the sort of fundamental feature but problem in blockchains, is we need to reach consensus. So every single node on that network needs to re-execute every single one of those transactions that the blockchain handles. So again, in this case, it's like the Apple example, but in this case, no server does separate work from each other. They all have to do the same work over and over again, 400,000 times in Ethereum's case. And this is a core property to why we use blockchain in the first place, because you're trying to create this sort of global, verifiable truth without actually having trust. So that re-execution is essential to it. But the problem in blockchains, again, is you cannot have every single computer re-execute everything. Like, blockchains don't scale. Anyone that tells you otherwise, like some of these other blocked Alt-L ones, are saying that they can scale, are either lying to you or unaware, or just it's marketing. There's a lot of marketing in this market. Like, this should be really, really obvious. No matter what fancy words they use, you can scale blockchain, period. Right, so blockchains have this sort of issue where they need to choose between either you make it very scalable by increasing the node requirements. You're going to start having beefier and beefier servers like Solana does, and it can only run in very, very few data centers in the world, which essentially defeats the whole purpose of blockchain. There's some point where, for example, Solana cannot keep scaling. Even they don't pretend like they can scale forever. They say they can scale at Moore's law, which, if you know about, it's 2x every 1.5 years. That's a really miserably slow rate of scaling, and it's going to take us forever to get to mass market if that's really what we're aiming for. Or you can keep the requirements or the scalability very low, but then you have maximally decentralized, more and more nodes creating this one global layer of truth, right? That's something that like Bitcoin and Ethereum optimize for. And as a layer 2, we can benefit off of that while still increasing scalability. And I'll get, like, this is what we'll talk about of how we can achieve that. So again, blockchains scale differently than the internet. So if you have one server with X resources, you have 1x scalability in a blockchain. But the problem is, if you have 10x servers or 10 servers with the same scalability or the same throughput, you have still 1x scalability. If you have 1,000,000 servers on this network, you still only have 1x scalability, which in Ethereum's case is like 30 transactions per second, right? So it doesn't scale with the resources that are allocated to the network. It just gets more decentralized, more secure. And so what about if we just use cross-chain? Like, what if we just keep copying Ethereum, making new versions, or do Ethereum to Solana? Please don't do cross-chain. Please don't do it. It's really unsafe. Like, that layer of trust in between will never be as secure as either one of the blockchains that it's connected to. And even worse than that, it becomes like, if one of the networks or on the entire connection list that cross-chain bridge connects to is manipulated or hacked or goes down, you can essentially steal all the money in all of the different blockchains. So it creates this extremely weak point that, again, completely removes the point of using blockchain in the first place. So you can't scale that way. Okay, so blockchains don't scale. It's all over. I should quit my job, go work at a bank. Screw it. We tried. We're sorry, Vitalik, we really tried. Don't worry, this is something that we were working on from the beginning, and we call this the ZK network. ZK's the end game. I hopefully I'll convince you by the end of this. So the ZK network is made up of two different parts, the core and the framework. And the core is actually what we use for ZK Sync Era. So if you've heard of ZK Sync L2, it's Era, and it's the first ZK chain that is on this a shared bridged network. And the nice thing is, like, any of the innovations that we make for Era, you can actually just keep copying onto new instances that are all based on this shared bridge. I'll keep coming back to this, but any one of these hyperchains or these ZK chains get the same benefits that we've been building in Era. So they become shards that all have the same features. In the future, with something we're developing called ZK IP, those shards can be actually completely different. So you could run Solana VM on this ecosystem, or Move VM, or a completely custom implementation that is not a full VM even. And it can still be interoperable in this connected ecosystem. So those core features, we've been building out over 5 years. Here's some of them, and we'll go over this list of core features. So again, we recognize this problem of, like, if you pretend that 30 transactions per second, or even 1,000 transactions or 10,000 transactions per second can get you anywhere, you're lying to yourself. Like, that's never going to scale to mass market adoption, right? So currently, each of our chains, again, have 200 TPS. Much more we have incoming. Like, we can get to 1,000, 10,000 per shard, right? And this is not as simple as it seems. You need to have a highly optimized virtual machine. You need to have a highly optimized databasing system, the network system. This took us many, many years to get to the point that we have the most scalable blockchain. And you'll understand that in a second. So for example, like, we have lower fees. It's on roll-up mode, it's about 3 cents a transaction right now. That's going to drop soon, even more. And with Validium, we're going to actually have lower fees than just about any Alt L1, especially if you understand how fees actually work in most Alt L1. So Solana transactions, for example, they cost 9 cents to 19 cents a transaction, but they essentially artificially inflate the token and just dump it on the community, creating people needing to essentially buy a lot just to keep the price stable. It's about, what was it, $8 billion a year or something that they dump on normal people to artificially subsidize the transaction fees. So these Alt L1s don't really have the fees that they pretend to have. In our case, that 3 cents is actually the cost of operating this network. Like, that's the real fee. With Validium, it'll really be a fraction of a penny. And we'll come back to why Validium's even better, because it'll stay a fraction of a penny forever. In fact, it'll just keep dropping. In these protocols, again, we've hyper-optimized also the prover of. People think that ZK, or zero-knowledge proofs, are the bottleneck in these blockchains. They're really not. We've hyper-optimized the prover system to the point that you can run it on essentially consumer-grade hardware, at least consumer-grade gaming hardware. So, like, my MacBook can actually run a full prover for a network because it has more than 6 gigabytes of GPU RAM. Like, that's really little. But our team has done an incredible job of optimizing it to that point. And one of the reasons that we have one of the lowest fees is a decision that we made early on, which is called state diffs. So instead of publishing every single transaction or every piece of every transaction, we essentially publish the delta, the difference between one state transition to the next. So for example, if I send someone in the school 1 ETH, they send it back to me. Then I send it back to them, they send it back to me, and this all happens in one batch. We don't update L1 at all, because that doesn't matter to security at all. Like, in the end, I still only have 1 ETH, and whoever I sent it to doesn't have that 1 ETH. So you don't need to actually publish anything to L1 to retain the security. Like, we still keep that data because your transaction history is important if you're doing taxes or seeing what you've done, but that doesn't remove anything from security. And this sounds like a small decision, and it's like, state diffs are confusing to people, but the reality is it's actually a massive effect, especially for getting like real TradFi applications or real world applications. So for example, it'll make any transaction cheaper in the first place. It'll allow you to have like stochastic price updates. So like in a Forex market or in a stock market, they don't update the Oracle pricing every couple minutes because it's too expensive. On ZK Sync, you can literally update the Oracle price thousands of times a second, and you don't actually pay, you only pay for one storage slot. So you only pay for once for saving that price difference, which is really remarkably different than any other blockchain. It enables extremely high frequency trading because you can make an order, you can cancel, you can change the price, you can keep like market makers, this really matters. In traditional finance, this super frequency really matters, and you can't do this on any other blockchain while only paying one storage, right? It allows much more complex transactions. It allows reoccurring payments, which people and banks need in their normal life, right? It allows a system of on-chain privacy, which we'll get back to in a bit. It's not possible to really have off-chain data in optimistic L2s. It's really not possible. Not securely. At that point, you become a side chain. And if you have off-chain data, you can essentially have a private chain. And like privacy has become this sort of bad term, but the reality is no business will ever deploy on blockchain. No bank will ever give away all of their customer data. The enterprises have trade secrets. They have customers that they don't want to put everything on chain. If everything's public, we're never going to reach normal businesses. So this is essential actually to be able to onboard all of traditional finance as well as just normal companies. Like Apple. Apple's not going to put their customer data on chain. If you do NFT mints, or like you have your identity as an NFT on a blockchain, you can do like massive batch mints of NFTs and pay one storage slot. It's much cheaper on our blockchain. And identity is actually really important because we're already working with Cork ID, who's the official digital identity solution for Argentina. So right now it's a choice whether you want a digital identity, but it'll be forced, it'll be essentially you'll have to get a digital identity soon in Argentina, which means every single person in Argentina will have their identity on ZK Sync. From there, you get a lot of more, like all the payments will start going because you can't have cross chain safely. Like we're gonna onboard the entire country of Argentina just because besides the fact we have scalable technology, that NFT minting actually matters. If you guys have played around with blockchain, you'll figure out that it's quite clunky, the UX. It's not great. There's a lot of signing where we're kind of like the internet was in 1995 for user experience. And honestly, like genuinely one of the most core aspects to being able to make that in a way that a user never notices they're using blockchain is account abstraction. Except in our case, we baked it into the protocol, into the normal mempool. So we actually have native account abstraction, which allows even normal wallets like MetaMask, you don't have to worry about what token you're making a payment in, right? If you send USDC, you can pay the fee in USDC. But it makes every single wallet, including EOA wallets, these smart wallets. And that enables us a lot of things like social recovery of like, no one should ever have to deal with seed phrases. Even people that have been in the space for a long time, like stored in plain text at home, you should never have to worry about that. Maybe your bank can be one of the signers to recover your account. Maybe your mom, maybe your email account can be one of those. And then if a certain threshold of those people say you lost your account, you can recover it. And there's ways to essentially stop anyone from hurting you in that situation as well. You can have transaction rules. So for example, let's say I can spend 50 euros a day without having to re-sign a transaction. And this way you can do your normal groceries. You can like play video games or buy assets without signing every single transaction, which is just horrible UX. We have already the SecP 256R1 elliptic curve as a precompile. What does that mean? That means you can essentially just sign in with your phone, like Face ID or the fingerprint scans, or you can use things like enterprise security, like YubiKeys or WebAuth, to sign into your wallet. It stores the seed in the secure enclave, in the trusted execution element, and you never have to worry about signing things or where your seed is saved. It's saved in a passkey and it's secure, and you can just use your phone without having to worry about it. Right? You can do session key signing. So let's say you're playing a Web3 video game. In the future, it'll just be called a video game, by the way. You can essentially sign into that game once, and then you don't have to make every single move. You don't have to sign another transaction because you have a session key, and it lets you keep playing the game without signing in just once like you should. Another like core feature of like this is not possible in optimistic L2s. They're starting to advertise that you can have off-chain data in like Eigen or Celestia, but that's actually incredibly unsafe on optimistic rollups because that DA solution can collude and literally steal all of the funds from the L2, and it makes it immediately like the biggest attack vector. Those fraud proofs don't help you at all, and the entire Ethereum community and research community, as well as L2 Beat, all agree that optimistic rollup with off-chain data is actually a sidechain. It's not a rollup at all. It doesn't get any security in this case from Ethereum. And they actually like this. The reason why they're doing this is because optimistic rollups have to push all the transaction data for every single transaction on chain to get their security. And what that means is as Ethereum fees go up, optimistic rollups will get more and more and more expensive. Like the same way that Ethereum got to hundreds of dollars for one transaction, that's going to happen over time to optimistic rollups as well. So they know that they need off-chain data because it's going to get too expensive, and they have inferior older technology. So they're like pretending like this is safe, and they're betraying their values. With zero knowledge proofs, you can essentially take the state root of the Merkle tree and you can push that on chain, and then you can use a zero knowledge proof to essentially attest to the state transition. Right. In this way, you can actually have data off chain. It doesn't affect the security of the protocol even a little bit. Like, okay, a tiny bit, but basically nothing, because even if that data colludes or someone withholds, it can never steal any of the funds off of Ethereum. And one of the cool things is because, again, the most expensive part of a rollup is pushing data onto L1. This allows us to essentially have flat transaction fees. As Ethereum prices go up, these transaction fees will be virtually the same. It'll be fractions of a penny, and we have ways to make it cheaper and cheaper where it's massively scalable. We are security first. This is why we're an L2. This is why we build on Ethereum. This is why we use zero knowledge proofs and don't just trust some validator set or pretend like economic security can be safe. It's our first, second, and third priority, right? Just the last year alone, we spent $8 million on audits in just ERA, and that goes up really quickly. We spend a lot of money on it because it's essential, because all these, like cryptography itself is a matter of time, how secure it is. And a lot of people worry that for both optimistic rollups as well as zero knowledge proofs, that ZK, for example, is a leading edge like cryptography that's been only around since like the 70s, until it wasn't actually, okay, that's besides the point. It wasn't non-interactive until recently, but it's very new as far as mathematics and cryptography goes. So people are worried that maybe we implement our prover system wrong, or our circuits wrong, or our verifier on Ethereum wrong, and that's a legitimate concern. But what we can do is we can use trusted execution elements like Intel SGX, so you can run the same exact state transition, like all of the transactions essentially, through the zero knowledge circuit, and you can also run them on this just a normal chip that is used in normal everyday like enterprise consumer applications, including, again, the Face ID is the trusted element. And this essentially allows, if there's a divergence, like if there's something wrong with the ZK circuits, essentially this will allow you to, like Intel SGX in this case, can just freeze the protocol temporarily, and that'll make sure that no user assets can be stolen or lost. And this is actually one of the things that makes ZK actually safer than optimistic. And I know that's a uncommon opinion, but essentially to hack this system, you'd have to find a zero-day vulnerability in our ZK proofs. You'd have to hack Intel, like you'd have to find a zero-knowledge exploit in that. You'd have to hack two of our security councils, which are completely separate entities around the world. Like you'd have to hack governance on top of that, and then maybe you could steal something before the governance could freeze the protocol. Like it's virtually impossible. Like even a state actor can't really do this. And again, we were hyper-focused on being able to actually make blockchain scalable to the masses over 5 years. So there's a reason why we are Ethereum compatible and not necessarily 100% equivalent, because we need this to scale. That being said, over the last year, we've already built out support for all the major tools, Foundry, which is amazing, by the way, Remix, Hardhat, and we're making a massive investment into user experience, developer experience, and product, because we're the first blockchain that can actually scale to real-world applications. So now it's all about, how does your mom use it? How does your friend use it? How does no one have to realize that they're actually using blockchain? And part of this process for developers is we'll be coming out. We have an internal project that we're investing in significantly that'll make SDKs, so every developer, even if they're not a blockchain expert, can make these beautiful applications with amazing user experience that can actually not just be as good as Web 2 applications, but better. And we pledged to go beyond EVM. Like, that native account abstraction is a good example. We did that years before anyone else, and we are gonna, for certain things where it makes sense, we're gonna have to diverge a little bit from Ethereum to enable these world-class applications if Ethereum doesn't move fast enough. And we will do this in an open source way, so it'll keep contributing to back down to Ethereum, but we have to make certain steps to really enable this to get to a normal person. And all of these like little things that I described, state diffs, Validium, ZK in general, like these were handcrafted by a world-class team over 5 years to make it right from the beginning. That's why you haven't heard quite as much from us in the beginning, because we had to build the architecture to the point that we can scale. We don't want any quick fixes. We don't want to just not have proofs like for a while, because that's irresponsible and dangerous and doesn't help anything in this case. You have thousands of decisions every single day in engineering where, like, especially in a larger organization or medium organization, where it starts diverging more and more and more every day. So I know it's hard to understand the difference of like ZK L2s one from another, or L2s in general, but these are massive differences that can't just be slapped on. Like, optimistic rollups know that they have to move to ZK, but they can't just slap on ZK. They can, but that'll absolutely limit their scalability to 20 to 30 TPS. It's going to take a long time to make those proofs. So any of this sharding architecture that I'm about to talk about, it's just that you can't do that. No bank wants to have to rely on this kind of horrible mess of reorgs or possibly losing all their funds with off-chain data that isn't really a roll-up. You can't just slap on these decisions afterwards. It takes careful engineering over a long time. And so that's the core of every one of our hyperchains. That's where we're at today. But we've actually gone further than that again, because even if you say that 10,000 TPS gets you somewhere, it doesn't, right? So we worked on, and this was part of our vision from the beginning, something called ZK Stack. And that's the framework where you can easily spin up more and more of these chains. Even if the core is different, if the core is the same, you can just quickly spin them up, right? But the key part here for interoperability, for making it feel like this one ecosystem, this one chain, one internet, is zero-knowledge proofs. There's no way to fake this. Like, you can fake this, but nobody in their right mind, no bank is ever going to sign up for that risk. No like enterprise is ever going to want to hedge that amount of capital loss or rely on every single other actor. Like, again, this removes if you don't have zero-knowledge proofs and those chains can't trustlessly interact with each other, there's no point in using blockchain. A bank already has to trust another bank. Why would they want to deploy on this instead? They get limited benefits, and it's not enough to get them out of bed. Zero-knowledge proofs are essential. It'll be the sort of HTTPS of blockchain. And so ZK Stack, which is my product, is a developer-friendly modular stack that just makes it really easy for you to quickly boot up these different ZK chains that are all interoperable using zero-knowledge proofs. And as a ZK chain, you have a lot of different choices that you can make while still being completely connected to this system. So you can have your data in roll-up mode, or off-chain data in Validium mode, or you can have Volition, which is essentially both of them. You have a savings account and a spending account. Maybe it costs a little bit more on roll-up mode to make a transaction, but that's your savings account. And then you can have normal spending accounts on Validium where you can make lots of transactions for very little. Like you can choose different transaction sequencers, transaction sequencing layers to be centralized, not centralized. And again, that doesn't actually affect the user's security, even if they're using that and it has only one centralized sequencer. You can have different data availability modes, Celestia, Eigen, safely, again, being the key point, not making it a side chain. You can have private data, public data, and you essentially get a lot of choices in between. In the future, much more choices with zkIP, which is the part that I mentioned earlier for having different virtual machines and stuff. And ZK Stack is what enables, like, this is core, this framework model is core to how you can become like limitlessly scalable. Again, the internet can't scale on one computer. It scales by doing execution sharding. Apple cannot they can't fit their entire user database in one computer. It's impossible. It's just way too much processing. And this is how all technology scales, is by doing sharding, essentially, sharding of execution, sharding of resources. And ZK and ZK Stack is what enables blockchain to get to this without having those compromises that remove the whole point of using blockchain in the first place, and ultimately don't even scale to the place that people need. So again, we use zero-knowledge proofs to make these interoperable. So one bank does not have to trust another bank. If a bank from China sends a bank from Europe to Europe $1 trillion, nobody has to trust each other in this. Like, they know for a fact that Bank of China had those euros. They're not lying about some digital balance that who knows where it's stored. They don't have to spend hundreds of millions every single year on doing reconciliation, on doing auditing each other, on having these middlemen that you can't have transactions over the weekend or overnight that essentially steal money. If you're doing forex payments from one country to another, the amount that they steal from you is outrageous. But the reality is banks have to deal with this too. Enterprises lose a crazy amount of money in just doing these international settlements. Zero-knowledge proofs and not having to trust each shard, not having to trust each other is key to this. Each shard not having to run the executions for every single one of those chains or those shards, each computer, is essential to being able to scale to that level. And if you create this right, if you make the ZK proofs fast enough, which they're becoming, you can have your funds on one shard, for example, Chronos chain. You can send your ETH to a completely different, like Uniswap chain, for example. You can swap your ETH to USDC, and then the USDC comes back to you, and all of this happens in one transaction, without you having to need to know, where is this DEX, what shard is my assets on. Like, it just kind of works. Like, you can abstract away all of this in a front-end interface where it just feels like one massively scalable network. And this is, like, again, this is the point that creates this internet of value. The same way as internet, it becomes limitlessly scalable as long as there's resources on the planet left. But this is like the same way the internet works today. You might have your money in some bank. You might have it on some app. You can just walk into a store, you can spend it. You can walk to an ATM, you can withdraw money. You can you can use some online store to buy something. You can play a video game on some web server, and none of this has to be trusted. Like, you don't have to worry about how this interacts. It just works. And that's what zero-knowledge proofs and this sort of execution sharding enables for blockchains as well, without making compromises, getting every piece of benefit from the blockchain. And this concept is a little bit harder to grasp, but essentially, again, ZK is not our bottleneck. You can make a proof of each transaction, then you can take those different proofs and make a proof of proofs to represent the block, and then you can verify that in seconds. Then you can take all of those blocks, make a proof of proofs again, get a batch proof, and then you take all those batches and it becomes one proof that represents that ZK chain. And then you can take all of those ZK chains, make them into one proof, and at some point Ethereum will also be a zero-knowledge proof of blockchain. We're already working on it, like the Ethereum community. And then all of a sudden, you'll make a proof of every single ZK chain that is deployed on our shared bridge You can verify all of those on a mobile phone in milliseconds. So you know for a fact that millions of transactions were executed completely correctly in milliseconds. Like it enables the vision of like ultimate decentralization where every single phone can be a full light client. Your MetaMask is a full light client. Like this is a lot more exciting than it's easy to explain. And we call this concept ZK singularity, verifiable computation. ZK is the end game, right? And this is what enables blockchain to finally scale, to get to the promise that we all wanted. And the cool part of this sort of ecosystem that we have, actually, let me step back a little bit. So we already have like this really exciting ecosystem that's growing. It's honestly, it's a super exciting a time to be in blockchain. It's finally getting to the point of like, similar to the internet in like 1995, you didn't have scalability before that. And as more resources became available, network bandwidth, computing hardware became faster, all of a sudden you started having Google Maps, like you had social media accounts. That scalability was key to being able to enable these real product market fit applications. And we're already at that level. I literally spent this week talking to 4 different banks, a central bank, by the way, they're all deploying on us. Different enterprise uses. I mentioned Quark ID, which is the Argentinian digital identity system. In Argentina, 30% of people use crypto for their everyday payments and purchases, and the vast majority of them use Lemon Cash, which is kind of like a PayPal or a payment app. And they're building a ZK chain. We have the top Web3 social media, which really enables a new paradigm in social media. Again, harder to explain than it sounds, but it'll revolutionize the way that social media works. And they had to choose ZK Sync because it was the only option that could actually enable real market scalability. We have Kronos or Crypto.com deploying on us with addressable user base of over 80 million people. We have iCandy, which is the largest game developer in all of Southeast Asia and Australia and New Zealand, that are launching, going almost fully into Web3, launching games like assets for their media franchises. We have Fidelity, which is a massive, like okay, I'll leave the Fidelity one for later. You guys will see some announcements about that in the future. But so we have Space and Time, which is like ZK SQL. You can essentially have verifiable SQL queries, and Google's like really excited in them. They invested in them heavily. They're probably going to integrate it at some point into Google BigQuery, which is massive, right? They're launching a chain on us because they need a source of truth to have their verifiable execution. We have so many of these projects that I wish I could tell you. It's like, it's a really, really exciting day today. Like we are at the precipice, like the tipping point before launching into mass market adoption. And there's very few times in anyone's lifetime, if any, in human history where you have this big of a technology or innovation that's about to take over the world. And if you knew the day-to-day conversations that I have, you'd be just as excited, like heart beating excited of what's about to happen. And again, like important thing to realize here is like, these are not just some apps deploying on ZK Sync. Like Gravity is a highly qualified team. Like these banks, like we announced the Deutsche Bank Singapore Monetary Authority one, they are incredibly talented teams. And if, let's say, like ZK Candy makes iCandy, their chain is called ZK Candy, makes really cool games, then that doesn't just benefit them. It actually benefits like Crypto.com. Then they'll have more people coming, onboarding, adding money. And the more people they add money, the more iCandy will go up, or all these different like ecosystem partners. It results in this sort of exponential growth pattern. It doesn't grow linearly to the amount of resources or like in this case, I mean, like financial assets or users. It creates this sort of exponential growth pattern that takes over, the same way that if you've ever heard of network effects, the internet grew with network effects, which is an exponential pattern. Everything we make at Matter Labs, and this is sort of also a constitution for ZK Sync, is like we are Ethereum aligned because we believe that blockchains need to be, it's not even believe, it's like the whole point of blockchain, that they need to be secure, decentralized. Everything we will ever make will be completely open source, free to use, fork it, copy it, build on it. Like we're not gating it. It's for the public good. Every part of it is permissionless. Again, you can forget any of these ZK chains at any point when they want to divorce the protocol, can simply point their like contract and move the funds to another shared bridge. Like they don't get trapped in this ecosystem. No one can stop you as a user from withdrawing your funds from one of these ZK chains. Like it'll all be permissionless. And like, please join the future. Like you guys are the next generation of builders. Like this is a really rare time where you can get into an industry, you can be like very casually hanging out with the like essentially the equivalent of Apple, like Steve Jobs in a conference. Like it's you don't have to take yourself too seriously. You can like, if you can dress however you want, you can make silly jokes, like you can have memes and presentations. And I come from the data center industry. That was not the same. Like please come build on ZK Stack or just ZK Sync. As a dApp, like this ecosystem's about to grow very quickly because we built the fire and we're ready to essentially ignite that fire to grow. And all of our ecosystem partners are launching. So it's a really good time to come in. For those of you that use, I still want to call it Twitter X, you can follow me at ZK Lumi. And for any sort of official announcements on ZK Sync, you can follow ZK Sync at ZK Sync. If nothing else, like the thing I want you to start thinking about, to start taking away is like zero-knowledge proofs is a new type of cryptography. It's a new type of mathematics. It goes way beyond blockchain. Like anytime we came up or found a new field of mathematics, it changed fundamentally how we understood the worlds behind us. It fundamentally changed what we can build. Maybe it'll start actually explaining parts of quantum physics or black holes. Like it's math, right? Like you should be incredibly excited. This ZK is going to be like same way as the little lock bar on your browser. It's going to be embedded fundamentally into the internet, into your normal identity solutions. It goes so far beyond blockchain. It's math. Like when were you last around when they not really invented a new field, but essentially invented a new field of mathematics? And again, with the permissionless or open source, feel free to download it, fork it, share this presentation, do whatever you want to it. That's it. And we can take some questions as well now if you guys have any questions on this.
Thanks, Daniel, for this lecture. It's really exciting to see all the innovations that are happening in ZK. A question I have is, can you elaborate more on how exactly ZK is helping with the bridging between these separate shards? Like how is interoperability powered by ZK?
Yeah, so essentially you can, if you're doing cross-chain bridging, these are non-deterministic programs. And by the way, the cross-chain bridging is the same thing Optimism will do. They just use fancy terms for it. Essentially, blockchain A can never know the state of blockchain B because they're non-deterministic programs. There is no way for them to know what the state of the other chain is. With ZK, you can essentially run that computation and then cryptographically, mathematically prove that state is completely correct, right? But even then, there's a lot of bullshit now going around, like ZK cross-chain bridging. It's like, okay, you can have a zero-knowledge proof of the state transition, but what's the correct state? Like Ethereum might just fork. Like maybe someone can literally fork Ethereum on their own computer and say double spend over and over again, but be like, make a real, verifiable zero-knowledge proof showing I have all the ETH, and then you could steal the money from fridges. If you're doing source of truth that's cross-chain, you essentially need a multi-sig. You need a small validator set that attests to the correct state, which immediately removes the point of blockchains, right? Because now you have a tiny validator set. So what we do instead is we have one shared contract on Ethereum, and every single that contract holds all the funds. So when I send tokens from ERA to ZK chain C, I'm not actually bridging anything. It's like accounting, the same way that any blockchain works. If I send funds to somewhere else you just mark that it's somewhere else. That's how the ledger works, right? That's how our interoperability works too. And the way that you need to do this is like, again, chain A can't trust chain B. So essentially you commit off of chain B to the batch, to the newest state on Ethereum L1, which becomes your ultimate source of truth. Right, and then chain C can read that state commitment and verify the zero knowledge proof that this is really the correct state, and you know the source of truth because the source of truth is the same. If Ethereum reorgs, everything reorgs on top of it. If one L2 after the zero knowledge proof can't reorg and hurt the other chain, this is zero knowledge proof. That verifiable execution is essential to being able to do this trusted execution, and it's also trustless execution. And you also need a source of truth. It's critical, it's essential, and you can't do source of truth bridging. Like if we do this across like ZK Sync to Polygon, all of a sudden the latency is going to be incredibly slow. It's very expensive transactions to do cross chain. Like you need to, that's bridging. In this case, it's accounting, right? It costs you essentially next to nothing to send funds from one chain to another, and you can make them really, really fast. In the beginning, somewhere around a minute, and as zero knowledge proofs get faster and faster, which they are getting faster really quickly, essentially it'll become almost instant.
All right, that makes sense.
Instead of waiting 7 days for every transaction to confirm, which optimism will fake, but again, this is not gonna scale. The money required for it, the risk that everyone has, both financially relying on every single person, and it's the weakest link problem again, or literally just not like if you have interoperability in this optimism system, you're back to the problem of one computer needs to re-execute everything. Every single person has to have every single node running to have any source of truth. And even then, it's like you're relying on that small validator set to not steal your money or lie, especially if the data is off-chain. Do not do off-chain data. Don't do cross-chain bridging.
Yep, that makes perfect sense. Yeah, I don't think I have any other questions.
Yeah, I wanted to ask one question.
Mhm.
Yeah, you mentioned that we can run any VM on these hyperchains. So
You would be able to, not right now.
yeah, okay. So like if I have a VM that has like different opcodes, like whatever like Arbitrum is doing, kind of they are using WASM based opcodes. So would we be able to run that kind of VMs? Because like that will change a lot of how the like VMs would work. Like normally the VMs would only have changes in the application layer or their runtime architecture, but since now the opcodes are being changed, it makes a lot of difference.
So first of all, Arbitrum's I like the stylus idea. Like it's really cool. It's not quite as good as they advertise though. They literally have live demos where it's like they try to copy a cryptographic library and it just doesn't work, right? So there's more intricacy to it than it seems. But essentially, you only really need to across VM, you only really need to protect certain operations. Like if a person sends someone money, you need to protect that operation because otherwise they can send it over and over again, double spend and steal money from a different VM, right? So we can essentially make a very minimal set of requirements of like you can't double spend, you can't send the same funds twice, and then essentially you can use any virtual machine on top of that, only protecting those certain things. So and then you can do this verifiably. And this way you can have Solana VM completely trustlessly on this network without anyone being able to steal anyone's funds. You can have Move VM. It's more exciting than just like VM, right? Like I could have my own account as my own rollup, but in this case, now I'm only running transactions for myself, right? So I could have literally a rollup that only defines the count logic. It doesn't have to have every opcode, every precompile. It doesn't have to have any of this. It just needs to update like key pairs and do certain operations like sending. And you could have this tiny minimal state, minimal functionality rollup that, by the way, now is much faster to ZK prove. and then I can interact with any other application on the network. Like, it's not as small as VM. This is like when we talk about ZK as the endgame, this is a large part of what we're talking about, and this is not something we talk about publicly yet because we want time to essentially like really flesh this out. The ZK IP thing is very far. Like, we know how we're going to do that. We know how we're going to do all of this. We just need time for engineering. Like, this is not just going to create the next generation of scalable blockchain. It's going to create the next generation of like blockchain as a whole. All of a sudden, like, you can use an internet, you can use .NET, or you can use WordPress, or you can use whatever you want. This is what this enables for blockchains. It doesn't matter what virtual machine you have. It doesn't matter what language you're writing in. It doesn't matter what type of rollup you have. It becomes this massively, let me get that chart back up. It's a good way of visualizing it. Every one of these little pieces can be completely different, but they can all talk together and interoperate. So it really creates a whole new paradigm in blockchain.
Yeah, makes sense. Thanks.
No problem. And again, you'll be able to write in Rust or C or like whatever language you want. The virtual machine can be written in just about any language.
Hey, Daniel. I had a question basically. So you mentioned about recurring payments using the ZK stack. So basically, currently how it works is in centralized banks, basically the companies collect our credit card data in order to process the recurring payments. So how exactly it's going to be different using the ZK stack, and like we are not gonna like lose our like financial security credits, etc.
So this is a loaded topic. There's so many different use cases in which you could do it. But let's say you took a loan for, I don't know, a NFT, a car or a house. Essentially, you can pre-sign and you can have conditional logic where essentially once a month, only once a month, this entity can trigger a move of money from your account, and it can only be this amount or less, and they don't need interaction from you to do that. Right, and the how state diffs makes that cheaper is a complicated topic that let's not go into right now, but that's part of the native account abstraction part as well. So like, this is just one example. There's many different ways that you can design this, right? You can have like, if you like lose access to your account, maybe you can withdraw like 1/10 of it a month, and then it would take someone 10 months, even if they somehow corrupt your guardian set, like they corrupt your bank and your mom and your friend or whoever, right? It would still take them X amount of time, like 10 months to be able to take out 100%. And at that point, you could essentially remove them from the validator set. Like, that's a sort of reoccurring payment too. There's so many different avenues you can take the recurring payments to in a way that's trustless and doesn't just screw over the user.
Yep, that's great.
And we do have 5 more minutes if anyone has any other questions. Okay, well, that's it. Yeah, it was genuinely a pleasure talking to you guys. I can't wait to see the things that you'll build. Hopefully on ZK Sync. I'm not gonna push that like blockchain as a whole. If blockchain wins, I'm happy. I don't care who wins. We just happen to be a year or two minimum ahead of every other player. So by the time they catch up on trying to implement zero-knowledge proofs, which doesn't happen in a year, by the way, or try to get that 3 TPS to anything actually usable, like, we'll be much ahead of that. So it's a good, interesting place to build, but I really just hope that we can build a better system where like the financial, like the world economy is safer. It doesn't rely on one country lying and possibly breaking it. Like, we're trying to get that freedom, prosperity, and like, we need people like you guys, especially since you're young, to think about it differently and build a new world. You're going to be the ones in power in the future. You're going to be the politicians or just builders, the next like massive enterprises. You can change the world, and you don't have to change everything. You just have to change your own habits. And then if enough people make small decisions, it becomes this wave that's unstoppable.
Yeah, Daniel, thank you so much for having this lecture. It was a pleasure hosting you and hearing all these great innovations that are happening on ZK Sync and in the space of blockchain.
Amazing. Thanks so much, guys. Talk to you later.